Welcome back to Understanding Exceptional. I'm Dr. John, and today's topic is math learning disabilities or disorders, or dyscalculia, another one of these fancy terms. So, what we need to do first is understand what is dyscalculia. And like all of these different disorders, disabilities, all of these labels, if you ask 5 different experts, what is dyscalculia, you're going to get 5 different answers because there isn't a single definition. The word itself, dyscalculia, is an opportunity to bring new tools to the table. And what the word suggests is that this individual's brain, the brain systems, are operating differently as it relates to learning mathematical concepts or calculations. And so brain systems that do those things differently don't often respond the same way to the general curriculum. And so we need new tools. And so when we have brain systems that do conduct and learn math operations differently, we see that in their behaviors. And then we look at the behaviors and we say, well, we're really struggling in math in this area. And so we need to call it something in order to get those new tools. Again, we're locked into this ridiculous system where in order to get new tools, not less than tools, but in order to access those tools, we got to call it a word, because if you're not like everyone else, something's wrong with you. Totally wrong. It's the system that's wrong. Nonetheless, we use that system. Dyscalculia gets us to new tools related to math learning differences, which are born from the brain and result in what we see in the classroom or at home, frustrations. So what is it? So mathematics is a process of learning symbols and associating quantities with those symbols. So numbers, of course, are symbols. And then it becomes a process of looking at various symbols and executing a series of steps. So we can understand the quantity or the quantification of those symbols, whether they're presented in like a traditional format, a math problem that you're accustomed to seeing, whether it's 222 plus 312. So that would be a more traditional sort of math calculation algorithm, or if it's presented more in a story problem. And there tends to be sort of a bifurcation. If you struggle in one, it doesn't necessarily mean you'll struggle in the other. However, if you do struggle fundamentally with the calculation piece, typically the story problems are challenging. But you do see a number of people who struggle with the story problems because of the reading element, but their calculations are really, really strong. And so we'll talk about that here in a moment. So dyscalculia from a brain standpoint, we've got to learn to associate symbols with quantity and understand various symbols, whether it's graphs, whether it's numbers, whether it's a set amount, we're counting teddy bears. We associate numbers with symbols and symbols with quantity. And then, so that's the initial stages. So dyscalculia, like dyslexia and frankly dysgraphia, it isn't something that's acquired in 2nd or 3rd grade. It's evident early on, age 3, 4, 5. How is it evident? What we see is that the pairing of quantity with symbolic forms and understanding quantities and symbol relationships tends to be more difficult early on. So how might this manifest? Well, it might manifest in initially just difficulties recognizing the number 1, 2, 3, early numbers. It might manifest in struggling to understand sort of more than, less than concept. Which pile has more pennies? Over here, where you know there's 14, or over here where there's 5. So can you point to the one that has more? Can you point to taller? Can you point to shorter? Can you show me which one's under and which one's above? These are all, at the end of the day, aspects of quantitative thinking. So if your child is showing some challenges in these areas, we want to start focusing our lens on, are we going to start to see behaviors that require interventions in mathematics? And as always, the earlier we intervene, the better, period. It will always be true in every case, physiologically, neurologically, and certainly in relation to learning. So if you're seeing those early indications, 3, 4, 5, where we're struggling with learning number names, number quantities, we're struggling with quantities like more than, less than, taller than, shorter than, above, below, we want to really, really now focus on, are we looking at something where we need to intervene quickly? So that's the first iteration of behaviors. And then as kids transition into kindergarten, 1st grade, we start to do addition and subtraction, just the basics. a lot of very bright kids, which is almost everyone I work with. Everyone's bright in their own way, but a lot of the individuals I work with where I diagnose dyscalculia are intellectually very, very strong. And so what we start to see early on is maybe some blips where it's 1 plus 3 more in a horizontal orientation. And they're putting their answer somewhere that's not next to the equal sign. So they're not understanding the sequence here, 1 plus the equal, and it goes behind it. Maybe they're starting to reverse a lot of numbers, or maybe they're just simply miscalculating. They're not understanding the quantitative relationships and what comes next in the sequence. There's going to be your earliest manifestation. That's going to really hit the radar. Kindergarten, really in kindergarten, actually. And again, the use of a wait to fail model. Let's just give them more time and see if it works. Disaster. It's why our special education system's a total disaster. Another discussion. So for another time. But so as we start to see, if the brain is struggling to understand those sequences, whether it's the sequences behind where to put the response, if the brain is struggling, the sequence of adding or taking away this amount from this amount, if the brain is struggling with quantity, we need to start looking at beginning interventions, and we'll talk about that in the second half of this particular video. A lot of times what I see with these bright kiddos is those early on indications are there. 1 plus 3 is, instead of putting it next to the equal sign, they'll put the correct answer 4, but they'll reverse the 4, that's a sequence, and put it in the left-hand corner instead of next to the equal sign. So what I am seeing behaviorally is an individual who gets the quantities early on and gets the sequential or the additional aspects of it, the computational addition, but is struggling to understand that the larger sequence of it goes from this plus this equal, put it there. So what I will then generally see from these kiddos is situations where as soon as you start the process where the sequences really, really matter, borrowing, carrying, regrouping, this is where it really starts to break down. And this is where I commonly, we want to catch dyscalculia early in the process. And we have those clues early on, and then we can really start to see them when the multi-step procedures kick in. Now, ideally, we're going to intervene before we get there, but that's really hard to get somebody to move on that, because if the quantities are still known and we wrote a 4, even though we wrote it backwards in the wrong place, we're thinking everything's fine. We just got to learn to put it in the right place. But it's telling us that these sequential brain systems, these algorithmic systems related to quantity are developing differently. And so then moving forward, what happens is a lot of these very bright kiddos learn the sequences, and sometimes they'll do the operations the right way, and then sometimes they're like, do I start on the left? Do I start on the right? Where do I? So what you'll see is in most cases not an absence of the ability, but frustrations related to consistency. So these are the kind of kiddos you put a worksheet in front of them, and they get out of 20 problems, they get 13 right and 7 wrong, and you're like, well, wait a minute, if you got those right, it's all the same steps. You should have gotten, what's going on? You're not paying attention. You don't care. You rush through it. The brain gets tripped up a little bit in those sequences, and there's ways to remedy that. There's interventions available to enhance the process of consolidating or learning those sequences. So super important that we see those early indications of dyscalculia, and those were some of the earliest indications related to quantity and then algorithmic procedures. The other area that we want to look at is if the sequence of like skip counting. So the other area where I start to see it manifest itself is when a child needs to start learning 2s, 2, 4, 6, 8, 10, up to 20. We start to learn skip counting. What will a lot of times I will see if we're going to go with dyscalculia, which is evident because we want to change the intervention process or the curriculums. Sometimes they're there and sometimes they're not. And the more challenging ones are much, much harder to learn. So these kids a lot of times spend a ton of time every day trying to learn these sequences. Sometimes they get them right, sometimes they don't. Then they go and they take fluency tests, and it's a disaster. And in many cases, when we have dyscalculia, we need to eliminate fluency tests, not to enhance fluency. We need to keep working on that. but we need to eliminate those outcomes that we know are going to bring down the motivation because the success is very low. So if their friends are getting 33 done in the 2-minute interval and they're getting 9, that's embarrassing. And so those fluency tests, they give us an indication of how consolidated or crystallized the individual's information or their knowledge is about how to run those mathematical computations, whether it's addition or subtraction or multiplication. The faster you can do it, the more automatic it is, the easier it is for you, the more accessible and the more learned it is, the more you have available to you quickly because it's in your knowledge base. So if we're starting to see struggles on fluency tests and it's impacting self-esteem, we don't necessarily get rid of the tests themselves, but we get rid of the idea that we're going to calculate that or even demonstrate that to the individual. You only did this and you should have done that. We get rid of fluency when we're starting to see breakdowns there. So dyscalculia can manifest itself in a variety of ways. You can see it in a variety of forms, and it's only reflected through behavior, remembering that you can't have a behavior ever. It's never happened without a brain. And so if we want to understand the behavior, we need to understand the brain. And the brain that's related to dyscalculia simply learns how to associate quantities and symbolic forms differently. They may learn how to skip count differently. They may learn aspects of story problems differently. When it comes to story problems, generally what we see is if you're struggling with the calculations, of course, the story problems are challenging because there's calculations embedded within those. But like I had mentioned earlier, we do see a large cohort of individuals who are rock stars as far as the calculations, but as soon as you introduce story problems because of underlying learning differences related to reading, they struggle. So there's different avenues you can take. There's math problem solving that you can qualify for an IEP curriculum modifications, and then there's math calculation. And so they're sort of bifurcated in that regard because you can have one and not the other. So that word itself, let's summarize. What is dyscalculia? As with anything, dyscalculia is simply a word that opens up opportunities to look at different tools so that the individual who has a brain who does it differently can apply their effort to achieve the levels of success in mathematics that they desire and deserve. So the word leads us to a set of tools. And we can start to identify early indications of differences via keeping our eyes open and looking at a kiddo's development as it relates to quantity and symbolic forms, understanding various aspects of sequential processes and so forth. So we want to keep our eyes open if any of those are of concern. Also recognizing that if we see blips in any of those areas, it doesn't automatically mean we have dyscalculia. We have variability, of course, but we want to make sure that we're keeping an eye on this process and the behaviors that result so we can bring forth interventions as early as possible. Early intervention, the best intervention, always. So let's move into that. We've come up with this idea, dyscalculia. We know we need new tools. What are some of those tools? Well, to start with, there are really powerful curriculums out there. I'm not going to name any. I don't want to necessarily endorse any, and they're always changing. But there are curriculums out there that use different modalities of learning to drive home concepts related to quantity, to drive home the idea of how to execute multi-step operations or algorithms. So there's a lot of really wonderful curriculums out there. If you have your child already participating in some form of intervention, obviously before doing anything after this video, consult with those who are working with your child, anyone that you trust, and put it all together and figure out what are going to be the best interventions for my child. How do I ensure that their effort is equal to their success at the greatest level possible? That is the most motivating outcome on this planet, is success for almost every child. That's what they desire more than anything, making people proud. So how do we get there? Those curriculums can be a part of that. Eventually on the Understanding Exceptional platform and through that community, I may list out some of those. I'm not exactly sure how that works, if I'm able to do that. And I certainly don't want to endorse anything as being the solution or the intervention that will work for every situation. So do your research, figure out what curriculums are out there, and the overarching commonality among these curriculums is they change the dynamic of learning. So it's not just paper, algorithm, pencil, write out 1,000 different answers, go through these worksheets. Worksheets are a disaster. And this idea that more is better, more results in learning, never supported through neuroscience or brain science. What we know is that regulation and effort, attention, and motivation result in learning. When you have effort, when you have motivation to engage, when you have attention and executive functioning, and when you have outcomes that we're seeking and we can engage these systems, we are much more likely to achieve those outcomes, to learn. So we always have to keep that in the back of our mind, that learning is nothing more than an outcome and different tools can get us there. So do some research around those tools and find out which ones work best for you. A lot of them involve like more of a kinesthetic process, puzzles or hands-on or more visual instead of just manual writing. They're going to embed topics of motivation into the calculation process itself, make it more tangible, experiential. Those are the curriculums that generally are the most effective, particularly early on with interacting with this brain who just does it differently, the brain that does it differently. So again, exploration into some of those tools, I'll leave that up to you guys as individual families. So this is going to be very redundant, but we want to understand that learning is an outcome, and it's dependent on the principles, that it's depending on the brain science that we're familiar with related to how do we ensure or enhance motivation, because motivation is learning. Keep that in mind, store that one away. Motivation is learning. Think of your own situations. If you have to watch a movie, something you very much enjoy, but you've never seen it before, your ability to attend, to regulate, to take away information while watching that movie is enhanced. You're forced to watch something that's a disaster. It's much harder. It's harder to regulate. It's harder to pay attention. It's harder to not be on your phone. So motivation is the key to recalibrating the brain functioning so we get to learning. So how do we motivate, or minimally, how do we not reduce motivation through the way we work with kids in terms of mathematics? And we want to do that the same way we've done it during the last two videos related to dyslexia and dysgraphia. We want to eliminate ambiguity. So instead of focusing on a set number of problems to complete, here's 5 worksheets, we need to get through these. Once we get through them, that last question, that's your finish line. When you finish that last question, you're done. So now if you think about motivation, motivation is, I just want to be across the finish line. Math's not my forte. I'm probably going to get a lot of these wrong. I just want to be done. So we're working against the principles of motivation because we've changed the motivation to the number that we complete as opposed to the quality of our effort. And so that's really, really important to understand that. So as it relates to math, we're going to do, in this case, 2 5-minute math intervals. I know that doesn't sound like much. And of course, you can add to this if you want. But I'm telling you right now, less is more as it relates to motivation, attention, and learning. So we're going to do 2 5-minute math intervals that are not ambiguous in terms of time. We're going to use a timer. Whether it's on the computer, wherever the timer may be, I want you to use a timer because I can see the finish line. Math is not my favorite. You're asking me to put in effort towards math. Okay, but just for 2 5-minute intervals, I got it. And there's my 5-minute interval. And during this time, I need to be giving you effort. You need to define these things for these kiddos during this intervention process, or for young teens and adolescents, define the time. If we're defining the time, we're eliminating the ambiguity of effort. We're going to apply that effort over a set period of time, and that we're shifting away from the outcome, the number that you produce, to the effort during that period of time is the expectation. We're going to have individuals that can regulate at a much higher level. Their learning will go up exponentially. So 2 5-minute intervals, you set the timer. And let's take a 7-year-old who's learning how to regroup. So through addition, we are carrying, right? So what you say is, all right, we'll call this individual Janie. So Janie, we're going to do our 2 5-minute math intervals, or they're just your brain workout in math. 5 minutes, not the end of the world. Remember, you have your menu of motivators to pick from, 5 minutes here, 10 minutes there. So I need effort during this time. Here's what effort looks like. We're going to go through these problems. I need your eyes with me. your ears open, your mouth moving when I ask. And what I'm going to have you do, I'm actually going to model this first, is for each problem, you're going to separate the columns. So you're going to divide the columns. And then on each one, I'm going to put a little star on the right column. All right, so I know I start where the star is. So we're going to add those two. And for each column, except for this last one, because there isn't a line in front of it, we can only put one number. So if it's 6 plus 9, then we're going to put a 5 here. Now, it should be 15, but we can't put the first number down because we have another column we have to fill. So let's bring this 1 over here. And now we have to add the 1 to this column. And whatever we get here, we can only put one number. Whatever we have left on the front end, we have to take it over to this final column, and then we can put the final number. We have no other columns left. So hopefully that made some sense. But what we're doing is we're dividing the columns. We're organizing her approach to learning the sequences, as opposed to saying, go, get these done. You got to get to problem 30. We're really focusing on the quality of her effort. Now, if your child is lollygagging, they're not doing what they need to do, well, they're not earning their effort requirement. So you can either start another 5-minute interval or just they don't earn what's on their menu. That's the better option. But their effort is equivalent to something they enjoy. And effort is not perfection. So if we're still struggling with learning the sequences, there's a reason for that. So we really focus on each individual problem. I am telling you right now that in most cases, if Janie here does 5 problems and there was 25 problems on the worksheet, she got 5 successfully done, or she worked through them in the 5-minute interval, she's going to learn those steps and those procedures so much better than she would have if she knows her expectation is 25 and she just wants to get them done. This is why a lot of times what parents will tell me is that, well, I have my child do math problems. We roll through a worksheet. You know, they get a worksheet at 5 worksheets at the beginning of the week. We start rolling through them. On Monday night, they were able to do the problems. A lot of them, they seemed to understand it. I put the same worksheet. It was literally the same one. I made a copy of the same one just to see. They couldn't do it. So here's what happened in that scenario. Their motivation switched to, I want to be done. The finish line is this number of problems. So learning the sequences and the algorithms, yes, I'd like to do that, but I need to do that in a reasonable amount of time. And a lot of times, brains like this, our assumption is that's going to take me an hour and a half. We as parents know it's not going to take that long, but for a kid, it's overwhelming because I'm going to put a lot of effort in. I'm not going to get success. So if now my effort is tied to my success, that's the expectation. And I'm learning along the way. And I did 2 5-minute intervals, which equate to something motivating over here. You got me locked in. And so just structuring the approach to how we're learning these things. Don't provide a lot of ambiguity of time, meaning you've got to get a set amount of problems done, and the time is dependent on how quickly you do them. We're going to focus on the level of your effort over a set period of time, and your effort is all I'm asking for. You're going to see steeper learning trajectories in those scenarios. It will happen in most cases. Obviously, if you already have situations where you have interventions taking place, consult with anyone and everyone that's already working with your child. Get perspectives outside of mine. Talk to the people you know and trust to make sure that you pick the best intervention option for your child. But the larger takeaway here is that quantity has never been associated with learning in a meaningful way. The quality of effort always has. And if our efforts equal our success, we're motivating the individual through their successes, through their engagement, which creates a scenario where success leads to more motivation leads to more success. And it's a positive trajectory of both learning and self-confidence and self-esteem. So hopefully there was something meaningful in all of those different directions I took there. Things to think about, things to consider with the people that you trust working with your child. And with that being said, if you want to learn more about the human experience on all levels, whether it's education, special education, psychology, any of those, come and join us at understandingexceptional.com. And as always, like, subscribe, ask questions, make comments. Really appreciate you engaging in this community, and I look forward to seeing you on our next video soon.